Today you guys will be learning lesson 9.3 on solving quadratic equations by graphing and by using square roots. Okay, remember, a quadratic equation is an equation that can be written in the form of ax squared plus bx plus c equals 0. Okay, these really are what we've been working on before, okay, but we were talking about them as quadratic functions, but now we're talking about them as equations. So now these are set equal to 0. Okay, this is called your standard form of a quadratic equation. Okay, so everything is on the left side, and on the right side you only have 0. Okay, remember, these are quadratic because that x is to that second power, making it that quadratic function. Okay, these equations can have one solution, two solutions, or no solutions because their graphs are parabolas. Okay, they're that U shape, and depending on where that U shape is, depends how many solutions we have. Okay, so what they look like. Since these equations are set equal to 0, we know that the y-coordinate of the function must be 0. There's no more y's in these equations, so what we're really doing for the function is replacing that y with 0. What that means is that the solutions for these equations are actually your y-intercepts, because this is the only point where the ordered pairs are a number and then 0. Remember, your ordered pairs are x, comma, y, so we're replacing that y with a 0. Okay, therefore, these solutions are also called your zeros of a function. They're the answers where y is 0. Okay, one other thing they're called are the roots of the equation, because many of these equations we can solve by isolating that x squared and then solving for x by taking the square root. Okay, the first few of this lesson are going to really be review, because we're going to be solving by graphing, which is what we worked on in lessons 9.1 and 9.2. Okay, so remember, in lesson 9.1, we were graphing equations where they didn't have that middle term, okay, and then we right away had to make that table because we knew our axis of symmetry was 0, 0. Okay, if it does have that middle term, it has that bx term, then remember, you need to find your axis of symmetry, your vertex, plot your y-intercept and reflect it, and still find one other point so you have a good U shape. Okay, so those are still going to be the first steps, but now our last step is going to be to identify the solutions by determining the x-intercepts of our graph. So we're looking for where our parabolas cross the x-axis. Okay, remember, that's the horizontal one. So if I look at this example here, I have 1 point, one solution here at -1, and one solution here at 5. So the solutions for this quadratic equation are -1 and 5, because that's where they cross the x-axis. So let's try graphing a couple of these. Okay, so I have the equation x squared minus 4x equals -4, and they want me to solve it by graphing. Okay, well, the problem with this equation is it's not set equal to 0. So the first thing I need to do is get that 0 on the right side. So what I need to do is get rid of that -4 by adding 4 to each side. So my quadratic equation is then x squared minus 4x plus 4, okay, equals 0. And once it's set equal to 0, I'm ready to solve. Okay, so I'm going to look at this equation, and you should see that it has that middle term. It has that -4x. So I have to use that axis of symmetry method. Okay, so remember, to find that axis of symmetry, we use the formula (b over 2a), which for this problem I have a -4. Okay, because if I identify my parts, I forgot to do that, sorry. My a term is 1, my b term is -4, and my c term is +4. Okay, so I'm plugging in that b, -4, but it's negative in my equation too, so I have a double negative up there, over 2 times 1, which gets me negative times a negative is a positive, so I have 4 over 2, which gets me an axis of symmetry of 2. So I'm going to draw that in using my dashed line. Okay, so after I find the axis of symmetry, remember you found the x-coordinate of your vertex, so your next step is to find the y-coordinate of your vertex by plugging that 2 into your equation. Okay. So my equation is going to become 2 squared minus 4 times 2 plus 4. 2 squared is 4. Negative 4 times 2 gives me minus 8 plus 4. So I really have negative 4 plus 4, which gives me a y-coordinate of 0. So my vertex is at 2, 0. Over 2, dot right here. Okay, so the next point I plot, remember, is my y-intercept. Okay, so that's your c term, and for this, remember, our c term was 4. So on my y-axis, I have a dot up here at 4. Okay, so to find the other corresponding point to that, I can make those hops to my axis of symmetry. It's 2 hops. So I go 2 hops the other way and plot a point. Okay, so to find those 4th and 5th points, I need to pick one more x-coordinate. And for this graph, in between those 2 points I already know, I have 1. So I'm going to choose for x equals 1. And when I sub in 1, I have 1 squared minus 4 times 1 plus 4, which gives me 1 minus 4 plus 4. Okay, and when I solve that, I have negative 3 plus 4, which is 1. So I'm going to have a dot at 1, 1. And to find that very last point, I again make that hop to my axis of symmetry, which is over 1. So going over 1 the other way, I find my final dot, and I can make my parabola. Remember, they should be a curve at the bottom, not a point. Okay? And the very last step, the only new part to today, is actually just identifying where your graph crosses your x-axis. So I'm looking at this graph, and I'm looking at my x-axis, and the only point on that graph for this one is my vertex. Okay, so this one only has one solution, and the solution is x equals, sorry, not x equals, okay, yeah, x equals 2. Okay, any questions on that one? Okay, so we'll try another one. If you had no questions on this one, it'd be a really good time to pause the video and try this next one again on your own before watching it. But you can watch this one too, because we will have one graphing one after that. Okay, so this one, the only thing that's different is I have x squared plus 8 equals 2x. So this time I still don't have it equal to 0, but now I have that bx term on the right side. So it doesn't really change my steps, but this time I just need to move 2x, so I subtract 2x on both sides, getting me the equation of x squared minus 2x plus 8 equals 0. Okay, so when I solve this or to graph it, okay, I need to look at my equation. I see that there's that middle term, so I'm going to use that same method I just did. My axis of symmetry is negative b over 2a. So let's identify our parts. My a term is 1. My b term is negative 2. And my c term is 8. Okay. So as I solve this one, okay, I'm going to plug in a negative, negative 2, because that b term is negative, okay, over 2 times 1. Negative times a negative is a positive, so I have 2 over 2, which gives me an axis of symmetry at 1. Draw that in with that dashed line. Okay, and now that I know where my axis of symmetry is, I can find my vertex because I know the x-coordinate is on that axis of symmetry, so my x-coordinate is 1. I'm going to plug in 1 to my equation, so I have 1 squared plus 8 times 1. Whoops, that's not right. Okay, minus, sorry about that, minus 2 times 1 plus 8. Okay, and when I solve that, 1 squared is 1, minus 2 plus 8, giving me negative 1 plus 8, which gives me a y-coordinate of 7 for my vertex. So my vertex is at 1, 7. Okay, and if I notice, this graph is going by 2's, so 7 is in the middle of that box. Okay, so then I'm going to plot my y-intercept, which is again my c term. In our problem, c equals 8. So that is right on this line, and I reflect it. It's over one top, one the other way, and it's reflected. Okay, now for this one, picking that fourth and fifth point get a little trickier because I don't have any numbers, whole numbers, between those two dots. So I'm going to choose the next positive number, which is x equals 3. And I'm going to sub 3 into my equation. Okay, so I have 3 squared minus 2 times 3 plus 8. 3 squared is 9. 2 times 3 is going to be a negative 6 plus 8. 9 minus 6 is 3 plus 8 is 11. So my next point is at 311, which is a little bit, or halfway between the 10 and the 12. Okay, so then I reflect that point over the axis of symmetry by counting my hops. There's 1, there's 2, so I go 2 the other way, 1, 2, and I put my next dot, and I draw in my parabola. Okay. Now remember, we are solving this equation, not just graphing. So when I look at this graph, remember to solve it, you find where it crosses your x-axis. And when I look at this graph, there isn't a single point down here on my x-axis. So this is one of the graphs where we have no solution. Okay? Because it doesn't hit that x-axis anymore. Okay, one more graphing one. Okay, so remember your first step is to get it equal to 0. So this time I need to add 5x to both sides. And I end up with x squared plus 5x minus 6 equals 0. Again, we have that middle term, so I need to solve by using that axis of symmetry. So I'm going to identify my parts. A equals 1. It's a beautiful A right there. Okay. B equals 5. And C equals negative 6. Right, so I'm going to plug that in for my axis of symmetry, which is negative B over 2A. So I have negative 5 over 2 times 1, which is negative 5 over 2, which is really a negative 2.5. Okay, and remember, this is just for our work, and it didn't start as a fraction or a decimal, so I could do it as either a fraction or a decimal for my answer. So I'm going to leave it as that decimal. Okay, so negative 2.5 is my axis of symmetry, so I'm going to put my dashed line right here. Okay, and once I have that, we're ready to find our vertex, which we just found the x-coordinate is negative 2.5. So I'm going to plug that into my equation. Okay, So what I really have is negative 2.5, that's in parentheses because the negative is going to be square root 2, plus 5 times negative 2.5 minus 6. Okay? Negative 2.5 squared gives me a positive 6.25. 5 minus or times a negative 2.5 is a negative 12.5, and then minus 6. Okay, so when I subtract that overall, I get a negative 12.25. Okay, so my vertex is negative 2.5, negative 12.25. Okay, I'm going to plot that on my axis of symmetry. And if you notice, our axes are going by 3s for my y. So I'm at negative 9, and then it's negative 12, and it's going to be right below that negative 12 mark. Okay, so not right on the line, but right below it. Okay, then I need to find my y-intercept, which is again your c term, okay, which for our problem was negative 6. Okay. So my y-axis, I have a dot at negative 6. And that is 1, 2.5, so a half, and then 1, 2. There's my other dot. Okay. And for this one, I don't actually have any positives that I can plug in. I can choose 1 if I want to, okay, but I'm not sure exactly where that'll land. It'll be on my graph or not. This graph does look kind of wide, so you can choose 1, but I'm going to choose a point that's in between these 2 dots. Okay, remember, if you can, you want to choose a point that's in between your vertex and your axis, and your y-intercept. So I'm going to plug in x equals negative 1. Okay. Put those black dots back in there. Okay, so when I plug in a negative 1, I have negative 1, that whole thing is being squared, plus 5 times negative 1 minus 6, giving me 1 minus 5 minus 6, and when I solve that, I end up with negative 10. So I have an ordered pair at negative 1, negative 10, which is going to be below that negative 9. Reflect it. It's 1.5 boxes. It's my half and over 1. And there's my other dot. So I can draw my smooth curve, my parabola, through those points. Okay. Now, the problem with this graph is that I can't tell exactly where it crosses my x-axis. Remember, your solutions are where it crosses. So I have to estimate and approximate where those are. Okay. Now, according to my graph, and the other thing with these is, remember, yours might look different when you have to approximate. So when we grade these, as long as you have these first 5 points in the right spot, okay, we will look at how nicely you do your parabola and see if your approximations are right. Okay, so my solutions from my graph, we'll just look at my x-axis, and I have a point right here and right here. So one of them is nice. Okay, one of them is x equals 1, but the other one isn't at a single point. Okay, these are going by 1s, but it's in between negative 5 and negative 6, but it's closer to negative 6. So I'm going to say negative 5 and 3/4. Okay, and that again is the problem with the graphing method and why we're going to spend the next couple days learning some other options. Okay, so the other option we're going to learn is the solving by using square roots. And this one's kind of like lesson 9.1, where you can only use it when you are solving for an equation that doesn't have that middle term. Okay, solving without that bx term. Okay, and what you do to use this method is you isolate x squared. So now we're no longer getting it set equal to 0. Okay, but we are getting that x squared by itself on a single side. Okay, and once we have x squared, in order to solve it, we can take the square root of both sides. Remember, a square root is your radical sign. Okay, and whatever you do to one side, you do to the other. Okay, and then by solving that square root, you can tell your answers. Okay, if the number under that radical, so your radicand is positive, you have two roots. Remember, they can be positive or negative. If the number under the radicand, or under the radical, the radicand is 0, you have one solution. The square root of 0 is just 0. And if that number under there is negative, you have no solution, because remember, when you square root a negative, you are getting an imaginary number. It's not really possible. So let's try some of those. Right? So solving by using square roots. My equation is m squared minus 36 equals 0. My first goal is to get my variable squared by itself. So if I draw this line right here, means I need to get rid of that negative 36. So I'm going to add 36 on both sides. Okay, so now I have the equation of m squared equals 36. And to find the value of just m, I need to undo that square. So I square root both sides, getting me m equals plus or minus 6. Which remember, you can write that as 6 and negative 6. Or you can just use that plus or minus symbol. Okay, but that one has two solutions because this 36 is a positive number. Okay, this method should save you lots of time because now you don't need to do all that work to graph. Okay, so let's look at a couple other ones. Okay, what are the solutions of 3x squared plus 15 equals 0? Remember, my first step is to get that x squared by itself. So my first step is going to be to subtract 15 on both sides, getting me 3x squared equals negative 15. X squared isn't by itself yet, so I need to divide by 3, giving me x squared equals negative 5. Okay, so to finish solving, I need to undo that square by taking that square root. And what I noticed this time is under that radical is a negative number. And I cannot take the square root of a negative number, so this one has no solution. So, the last example for today. Okay, 2x squared plus 13 equals 13. My goal is to get that x squared by itself. So I subtract this 13 on both sides, getting me 2x squared equals 0. Divide both sides by 2, and I end up with x squared equals 0. Remember, when the 0 is on top, your answer is 0. So to solve, I take the square root on both sides, and my answer is x equals 0. Remember, 0 is neither positive or negative, so there's only one solution for that problem. Okay, so those are the two methods we're learning today for solving quadratic equations. Solving by graphing and solving by using square roots. Remember, you can only use the square root method if there's no middle term. There's no bx term. Okay, so that's the lesson for today.